Right. Carbon forms a vast number of organic compounds. Carbon can share its outer shell 4 electrons. Carbon, it is in group 4, right? It has 4 electrons in outermost shell. It can share all 4 electrons. Carbon can share its outer shell 4 electrons with other atoms such as carbon, hydrogen, nitrogen, and oxygen to form stable covalent compounds. This carbon, with carbon they can make bonds, with the hydrogen they can make bonds, with the oxygen, with the nitrogen, he can make stable bonds. Carbon can form stable chain-like structures, covalent bonds with carbon atoms, such as carbon-carbon single bond, carbon-carbon double bond, carbon-carbon triple bond, carbon-hydrogen single bond, carbon double bond oxygen. So these kind of bonds you will see in organic compounds, and those are very stable. Those bonds are very stable. Right. Classification of the organic compounds. Hydrocarbons, you have heard hydrocarbons. Compounds which contain only carbon and hydrogen are known as hydrocarbons. So, compounds, if you can see only carbon and hydrogen, then we are calling it as hydrocarbons. Compounds which contain only carbon and hydrogen are known as hydrocarbons, like methane, ethane, propane, butane, pentane, hexane, those are hydrocarbons. Non-hydrocarbons, compounds which contain carbon, hydrogen, and other elements also there, such as oxygen, halogen, and nitrogen, are known as non-hydrocarbons. Hydrocarbons, especially if it is having carbon and hydrogen only. Non-hydrocarbons, with the carbon and hydrogen, you will see oxygen, nitrogen, and halogens as well. Right. Okay. So classification of the hydrocarbons. The hydrocarbons, the compounds that have carbon and hydrogen only, you can classify those into aliphatic compounds. It means open chains. Okay. It's open chains, aliphatic compounds, organic compounds, which have open chain like structures. This is an open chain here. See, this is an open chain structure. Organic compounds which have open chain-like structures are known as aliphatic compounds, like hexane, butane, hexane, heptane, octane. Those are open chain structures. So open chain structures, we are giving a nice name, aliphatic. It is an open chain. Right. Aromatic compounds, next year you will be learning. So it is not important for us now, but keep in mind we have aromatic compounds, organic compounds, which have cyclic structures with an aromatic nucleus. So in benzene, if you see the benzene, it is cyclic structure and it has aromatic nucleus. Those kind of compounds we are calling it as aromatic compounds. Some compounds are there one chain, sometimes you will see chains are fused like this. Those are aromatic compounds. Later, next year, you will be learning those things. Now it is not important. But aliphatic compounds, it is very important for us. And I remember drawing that. Yes, aliphatic. We need to. We have like a lot of drawings here. Aliphatic compounds, and other than this alicyclic compounds, that also very important for us. Alicyclic, it means it's a cycle. Open chain structures are there, cycles are there. See, it's a cycle here, and it's a cycle here. These are, we are calling it as alicyclic compounds. We have aliphatic, open chain structures like this, and we have alicyclic, it is a cycle like this. Okay, aliphatic, alicyclic. These are the two things it is important for us, not the aromatic compounds. So aliphatic we need and alicyclic we need. After that, we are moving to classification of the organic compounds, saturated and unsaturated. That part you know. What do we mean by saturated compounds? Abhyan, we learned in all levels. Saturated compounds, in the carbon chain, if you cannot see any double bonds and triple bonds, it is a saturated compound. Unsaturated compounds, you can see double bonds and triple bonds. Simple. Saturated compounds, organic compounds which do not have any double or triple bonds in the carbon chain, are known as saturated compounds. Right, like alkanes. Alkanes, do you see any carbon-carbon double bonds in alkanes? No. Alkanes, they have only single bonds. All the bonds are sigma bonds. All are single bonds. Unsaturated compounds, organic compounds which have at least one double or triple bond in the carbon chain are known as unsaturated compounds like alkenes, alkynes. In alkene, you can see double bond. In alkyne, you will see carbon-carbon triple bond. Okay, the saturated and unsaturated. Right. Now, molecular and empirical formulae. Actually, in organic chemistry, you are learning 5 types of formulae: molecular formula, empirical formula, displayed formula, structural formula, and skeletal formula. 5 types you are going to learn here. Okay. First, we'll move to molecular and empirical formulae. There are many ways of representing organic compounds by using different formulae. Actually, 5 types. The molecular formula of a compound shows the number of each type of atom present in one molecule of compound. Molecular formula means actually how many atoms of each element is present in the molecule. But empirical formula means what? The simplest whole number ratio. Okay? Empirical formula of a compound shows the simplest ratio of the atoms present. Check here. So C2H6 is the molecular formula. It means in that molecule, actually, you have 2 carbons and 6 hydrogens. What is the empirical formula? Can you simplify that one? Yes. You can divide both carbons and hydrogens by 2. So carbon 2 divided by 2, it is 1. Hydrogen 6 divided by 2, it is 3. So empirical formula is CH3, but the molecular formula is C2H6. Okay. So here also same thing. C6H12O6, that shows actually how many carbons, how many oxygens, and how many hydrogens are there in the molecule. But in the empirical formula, you need to simplify. You are dividing everything by 6. So carbon 6 divided by 6, hydrogen 12 divided by 6, oxygen 6 divided by 6, CH2O. C2H4O2, it is the molecular formula, and you can divide everything by 2. CH2O is the empirical formula. Neither the molecular nor empirical formula gives information about the structure of the molecule. So molecular formula and the empirical formula, it will not give you the structure about the molecule, but it will tell you actually how many atoms are there in the molecule. And from the empirical formula, it will give you the simplest whole number ratio. Now we'll move to displayed formula of organic compound, third type of formula. Now you have a clear idea about the molecular formula and you have a clear idea about the empirical formula. Now the displayed formula. Displayed formula of organic compounds. The displayed formula of the compound shows the arrangement of atoms in a molecule as well as all the bonds. By using the single lines and double bonds, triple bonds, you need to show all the bonds. That is what we are calling it as a displayed formula. Single bonds are represented by single line, double bonds with double bonds with 2 lines, and triple bonds with 3 lines. Okay, so the displayed formula can show the different structures of compounds with the same molecular formula. Right, okay. So displayed formula, when you are drawing the displayed formula, we'll think it is I have CH4. Okay, it is that is the simplest alkane we have, methane, CH4. Right. So for the methane, this is the molecular formula. And what is the empirical formula of methane? The same thing. Can you simplify this one anymore? No. So empirical formula also same. Now I'm going for the displayed formula. In the displayed formula, carbon, and you need to show all the bonds like this. This is what we are calling it as displayed formula. All right. Okay. So how about C2H6? C2H8, 2 carbons, and all the hydrogens you need to show like this. This is the displayed formula of C6. This one is methane, this is ethane. Right. So for the ethane, what is the molecular formula? C2H6. What is the empirical formula? You can simplify this one, CH3. This is molecular formula. and this is empirical formula. This is displayed formula. All right. So hope you got the difference between these formula, because we need to learn 5 types here. Right. So this is the displayed formula for ethene I have drawn here. So in between carbon and carbon, there is a double bond. So you need to show the double bond, and these are single bonds. Nicely, you need to show all the bonds. That is what we are calling it as displayed formula. The displayed formula can show the different structures of compounds with the same molecular formula. This is ethanol, it is an alcohol. Methoxymethane, it is an ether. They are having the same molecular formula. See, they are having the same molecular formula but different structures. Okay? Yeah, this is an ether. Why? This is an alcohol. Okay, this is an ether. Ether also, like alkanes, alkynes like a small family in organic chemistry. Ethers, esters, we have a lot of members in this organic family, but you know only very few. You know alkane family, you know alkene family, alkynes, you know alcohols little bit. You are learning everything. Okay, alcohols. After that, aldehydes, ketones, esters, amides, amines, ethers. Like they are like, it is a huge family, small sub families. Okay, right. We will be learning everything later, slowly. All right. So ether also small organic group. Here also alcohol is also small family in the organic chemistry. Right. Now we'll move to structural formula. This is the fourth type of formula we are going to learn. Molecular formula, empirical formula, displayed formula. Now I am moving to structural formula of organic compounds. The structural formula of a compound shows how the atoms are arranged in a molecule, and in particular shows which functional groups are present. Unlike displayed formulae, structural formulae do not show single bonds. These are very important. In the structural formula, you should not show the single bonds, but although double and triple bonds may be shown. So when you are writing the structural formula, single bonds you can't write, but if you can see any double or triple bond in the molecule, that one you can show. Right. Check this one. 2-chloropropane. So the displayed formula is drawn there. Now I will tell you how to draw the structural formula. There are methods to draw these things. So if you listen to me carefully, it won't be hard. If not, only you will complain. Carbon, carbon here, hydrogen. This is the displayed formula. You need to show all the bonds. Hydrogen, 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 here chlorine, and here hydrogen. Right. This is the displayed formula. But sometimes in exam paper they will ask you to write the structural formula. Now we'll see how can you write the structural formula. When you're writing the structural formula, start from one end. Okay, so it means so always start from the left hand side end and part by part write it. So I'm starting with the left hand side and part by part write it. This part is CH3. After this part is CHCl. After this part again it is CH3. This is what we are calling it as structural formula. Part by part you need to write. How can you write the structural formula for this one? Start from here, CH3 and another CH3 like this. Okay, right. This is molecular formula, empirical formula, structural formula, and here we have displayed formula. Okay, part by part you can write it. Right, okay. So here in ethene, we can see carbon-carbon double bond, right? So in the structural formula, they have shown the carbon-carbon double bond. So cold and dry. Why? You can reduce that one. It is 20 now. Up beyond. Did I do? 24 fine. Probably. Okay. Right. So in ethane, we can see carbon-carbon double bond. That one they have shown in the structural formula. And here also you can see carbon-nitrogen triple bond. That also they have shown in the structural formula. Right. Now I am moving to skeletal formula, the final one. Okay, do we have time? At what time are we supposed to? Yes, we have enough time. Right. Okay. Yes. I will finish a little earlier, okay? Because if I will do this part and after that we'll finish. Because if I teach everything together, you won't understand anything. And online class, they are half of them are sleeping. I know. So I will have problem again when I'm explaining this one. Right. Okay. So skeletal formula of the organic compounds. The skeletal formula of a compound shows the bonds between the carbon atoms. Did we learn this in O level? No, right? No. Really? No. You remember? Sometimes you might have seen. You didn't learn that one. Oh, no. Hydrogen atoms are also omitted, but listen to me. Now, when you are drawing the skeleton, only the carbon-carbon backbone only you need to show. We are omitting carbon-hydrogen bonds. All the carbon-hydrogen bonds you are omitting, other than every bond you need to show. All right? The skeletal formula of compound shows bonds between the carbon atoms. It means the carbon-carbon backbone we need to show. The hydrogen atoms are also omitted, but other atoms are shown. It is a line angle formula. Sometimes we are calling it as line angle formula. Right, okay, so we'll see how can we do that one. Okay, it is kind of interesting. We'll go with C3, H, C3H7. Okay, we'll go with this. Right. So first I'm drawing the displayed formula. Three carbons. 1, 2, it is 8. The CnH2n, right? So it is 3, 6, 8. Hydrogen, it is an alkane, okay? This is propane. Right. I'm taking the basic one, then you will understand how to draw this one. Now, can you see any carbon-hydrogen bonds here? Yes. You can see carbon-hydrogen bonds here. We need to omit everything. Can you see any carbon-carbon backbone? Yes. This is the carbon-carbon backbone. Right. Okay. Now, when you are drawing this one, so how many carbons you can see? 3. Very good. You can count. 3 carbons are there. Now what you need to do is, so guys, the skeletal formula like it goes like this, line angle structure like this. Each bend is a carbon. Okay, right. So this one, this start from here. It is a 1 carbon. How many carbons are there? 3. This is the second carbon, and this is the third carbon. That's all. That's all. That is it. Okay, that is it. It's very easy. Only the carbon-carbon backbone. Now we'll think, instead of this one here, we can see OH or something. Then that one you need to show. Then you need to show this one like this. Understand that? Only the carbon-hydrogen bonds you are omitting. Other than that, if you can see any special bond like CCl, COH like that, that one you need to show. Okay? So I'm thinking here it is hydrogen, so I need to omit that one. All right? That is I like this way more than drawing all of it. Right, okay. Now do this question. Abhi, take the book and do it. If not, I'll kill you. Online guys, take out your book and do this question, guys. Hurry up. Only this question. After that, we'll finish. Huh? Okay, no? Yeah. Online guys, can you please take out your books and do this question, guys? I will write all the answers on the board, okay? If you do it quickly, we can finish. If not, I will drag the class. Question number 1. It is C5H12. It is pentane. It is pentane, right? Now, alkanes, you know. Right. First, go with the displayed formula. I need all 5. What is funny? First, go with the displayed formula. All the bonds you need to show. 1, 2, 3, 4, 5 carbons. Hydrogens 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. This weight formula is done. After that, they are asking you to draw the molecular formula, empirical formula, structural, and skeletal. Now I am writing structural formula, okay? Part by part. This part first, CH3. After that, single bonds you don't write, CH2. Again, CH2. Again, CH2. Finally, CH3. Okay then. Again.
I forgot to. I didn't see the last one.
Structural formula. After that, I am going to skeleton. How many carbons here? 1, 2, 3, 4, 5. Other all are carbon hydrogen bonds. Those we need to omit. Only the backbone. 5 carbons. I'm starting from here. This dots, it is not compulsory. Yeah? No dots actually. But I'm putting a dot. Then you will understand there's a carbon. 1 carbon. Second one. Third one. Fourth one. And fifth one. Done. Okay.
Yeah, I've been unfollowed.
Right. What is the molecular formula? C5H12. And empirical formula also C5H12. We can't simplify anymore. All right. Okay. Go to question number 2. It is C3H7Cl. Displayed 1, 2, 3. 7 hydrogens. 1, 2, 3, 4, 5, 6, 7. 1 chlorine. And skeletal formula, 3 carbons are there, 1 special bond is there, 1, 2, 3, and the chlorine is here. Skeletal formula and structure part by part, CH3, second part CH2.
Is did you write empirical formula?
Wait, CH2Cl. First one, the same thing. This is molecular formula, empirical formula. Right, here displayed skeletal. This one is structural. Molecular formula also C3H7Cl, and empirical formula also same. If you can't simplify, molecular formula and empirical formula will become same.
Miss, could you lower the camera? We can't see the skeletal formula.
Oh, wait. Now okay?
Yes, thank you.
Right.
Miss,
Huh?
you did like this last time.
No problem.
It doesn't matter.
It doesn't matter.
Not that I don't know.
It doesn't matter. But I need to connect this now.
Oh.
It doesn't matter, guys. If this chlorine is up, doesn't matter. Down doesn't matter. Okay, I like this way. It doesn't matter. Right, go to the third one here. I will erase the first one.
When's the last one?
Yeah, we'll do the third one and we'll stop. Tomorrow in the online class, I will do the other parts. Huh? I will explain. C2H5OH. Displayed 2 carbons, 5 hydrogens, 1, 2, 3, 4, 5, 1 OH group. Structural formula part by part, CH3, CH2, OH. Skeletal, only 2 carbons, 1, 2. OH is there, OH. Molecular formula, C2H5, C2H6O, because this one you can add Empirical formula, you can't simplify the same thing. Okay? Done. No need to do question number 2. Tomorrow I'll continue with that part. Online guys, tomorrow we will have an online session. Okay, please join everyone. Don't sleep. Okay, I will give you some time in the morning to sleep. Like I will start the class around 11 o'clock. Then you can nicely sleep and get up. So I need to finish this part before the exam, and then I will have some time to revise.
Which one will they ask for most often in exam?
In exam paper, they will most of the time they are going with skeletal,
Yeah,
this
the easy
one
one.
and this one. Okay, these three. But it depends on the question paper and examiner. Some examiners they like about everything.
Like you?
Oh yeah,
Yeah.
thank you. Right, online guys, please wait for. Give me 1 minute, okay? I will mark the attendance quickly. Okay, guys, you guys can leave. Copy down the things on the board. After that, leave. Okay?
I know it's not
You have Islam, no?
very sad.
Islam is interesting for you guys.
Is it?
I don't know. Students say.
They're talking about what are they talking about?
Ninth loves it. It's his favorite subject.
Islam is very which
Absolutely.
one?
Talking about what?
Is it economics?
Yeah, economic most of the time. Yeah, economic marriages and all. Nice. I mean, interesting.
What is it about? Is Rahul something? I don't know what that means.
Okay, guys, then tomorrow try to join. Okay, I will tell you the time. Please try to join everyone. I'm continuing with this lesson. Don't miss any classes. Okay, have a good day, everyone.